All right, so we're going to go over the content from chapter 3. So you have all these special angle relationships, transversals, and parallel lines. This question says that A and B are parallel to each other. And so I made a list here of all the angles that are equal. So like 7, 6, 3, and 2 are all equal to each other. 7 and 6 are vertical. 3 and 2 are vertical, so they're both equal to each other. And then 6 and 3 are alternate interior angles, so they're equal. So this top list, these are all congruent, and this bottom list, these are all congruent. Excuse me. So, what we need to do is we need to figure out what relationship angle 2 and angle 5 have, since they are the two expressions that have x. Angle 2 and angle 5 are not equal, so they don't have a special relationship. But 2 and 3 are equal, and 3 and 5 have a special relationship. 3 and 5 are consecutive angles. They add to 180 degrees. So I know that basically if I substitute 2 in for 3, I know that these two are consecutive, so these two things should be consecutive. They should be supplementary, which means they add to 180. So I'm going to add them together. So 5x minus 8 plus 7x plus 20 plus 20 equals 180. And before I made this video, I made a little mistake trying to make a key here, and I actually set those expressions equal to each other, even though I knew I was supposed to set them equal to 180. And if you did that, you would get a negative value for x, and it wouldn't quite make sense. So if you get a negative value for an angle, just make sure you check in your work. So if I combine like terms here, get that. If I subtract 12 from both sides, I would get 168. And if I divide both sides by 12, I get, what is that, 14, I believe? I think you get 14. Yeah, so x is 14. That's not what it asked me to find. It asked me to find the measure of angle 7. Well, 7 is the same as 6, and 6 is the same as 3, and 3 is the same as 2. So they gave me angle 2, so all I have to do is plug this 14 back in here to angle 2, and that should be my right answer. So that's 5 times 14 minus 8. So what's that? 70 minus 8 is just coming out to 62 degrees. So 62 should be your final answer there. On this one, it gives me 2 and 8. 2 and 8 are also not equal to each other. They are also what we would call supplementary. 2 and 6 are equal because they're corresponding, and then 6 is supplementary with 8, so 2 is supplementary to 8. So we would be setting those equal to 180 degrees, same as the last question. So what is that? 5x minus 11 plus 2x plus 37 equals 180. Combine like terms. You get 7x on this side. When you combine like terms here, you'll get 26, and then subtract 26 from both sides. Kind of skipping some steps here. You will get 154. So go ahead and divide both sides by 7. What is 154 divided by 7? That's not something that I can do in my head real quick, but I should. It's 22. Never mind, I don't have to do it on the calculator. So your answer is x is 22. Not actually your answer. Angle 5, you have to go ahead and solve for angle 5. But angle 5 and angle 8 are the same, and they give me an expression for angle 8. So I can plug 22 in there. So 2 times 22 plus 37. So that's going to turn out to 44 plus 37. What is 44 plus 37? Is that 81? So this should come out to 81. So 81 would be your answer there. Onto the figure here, name the solid. This is a prism because not all of the faces come to one point. That would be a pyramid. This is a prism. This is a triangular prism. Triangular prism. Name a set of parallel planes. Well, there's only one set of parallel planes, and it's the top face and the bottom face. So we would say maybe BCD is parallel to AFE. Skew lines. Skew lines are not on the same plane, and they are also not parallel to each other. So an example of skew lines would maybe be BC. Come on, there we go. BC, and not on the same plane, so I can't use either of these top two lines that connect with that triangle, but I can use like DE. So DE is not on the same plane, it's also not parallel. FE and AE would also work as being skew with BC. So calculate the volume. The volume of a prism is the volume of, or is the area of the base multiplied by the height. So the base is a triangle. The area of a triangle is 1/2 base times height. So our volume formula will be 1/2 times the base of the triangle on the bottom times the height of the triangle on the bottom times the height of the prism. So that's kind of confusing because there's two heights in there. So let's go ahead and plug those numbers in. So volume equals, and I'll put 0.5 to make this easier, times base. The base of the triangle would be AE. AE is 12. Times the height of the triangle, which is the height of this. So that's GF, which is 8. And then times the height of the prism, which is BA, which is 5. So multiplying all those together, we get what? 240, I believe. I think this is 240. What is that? 648, 48. Yeah, so that's 240. So we go now on to circles. It says use this figure. AB is 16. So a couple things here with this. Since this is perpendicular and it's a radius, so YC, since that's a radius and it's perpendicular to the chord AB, it bisects. So this and this are equal. And then in return, these arcs are also equal. So AC and CB would be equal to each other. So we're trying to find arc BC. What do we know? We know arc AC is 71. So we also know that this one is 71. So the answer there for BC is 71. Arc WB. This one can be a little tricky. We're trying to find the arc here. So that's kind of formed by this angle in the center. And remember, these angles here are the average of the two arcs. So it's the average of 71 and whatever this arc is up here. But I do know those angles because that's marked with perpendiculars. These are 90. So I know that 90 is the average of 71 in the number that I'm looking for. So the way I do this is 71 is 19 away from 90. So my number over here needs to be 19 more than 90. So I would add 19 to 90 and I would come up with 109. So what that means, if I took a calculator out and I averaged, let's write one another. If I averaged 71 and 109, I would get 90, which is the angle that they cross at there. So that's how I would find WB. It's not the only way to find it, but yeah. So find the measure of AWB. So we have to find what's left here. But because we have 3 of the 4 arcs, we can just subtract them from 360 degrees. And what I should have available right now is I should have a calculator ready to go and pulled up here, but I don't, so I'm opening that right now. Okay, so here we go. Here's a calculator. So I have 360 degrees in the whole circle, and I already know 3 of the arcs. I have 71, 71 again, and then I have 109 up there at the top. I was going to say, so if that works out right, this should also be the same. So this should be 109. So AWB is 109 plus 109. So this is actually, what, 218? 218? And then 18 says find the radius of Y. So the radius of Y is just a point from Y to the outside of the circle. We do have some lengths here. Let me erase this junk I got in here. So again, what we do know is that AD and DB are equal. We were given AB, which is the whole distance across. So I know that like these are 8. And I was given YD, which is 6. So I have this little short side, I have this little side, and then actually I can draw myself my radius. So there's a radius from Y to the outside. And I have a right triangle with 2 sides. So this is Pythagorean theorem. You have both of the side lengths, so we want to square them and add them together, which is going to get me, I believe, 100. Yep, and then the square root of 100 is 10, so the answer here would be 10. All right, moving on. Find the length of SR. Well, arc length formula is your central angle, which we kind of called it X in our formula. So central angle divided by 360 multiplied by the circumference, which is 2 pi r. Okay, so if we're finding the length of SR, We have a central angle of 38, so we're 38 over 360 times 2 times pi times r, which is 35. Alright, so I'm going to type this in the calculator here, put the fraction in parentheses, so do parenthesis 38 over 360, close the parenthesis, multiply by 2 times pi times r. So we come out to 23.21, so 23.21. Find the area of this sector. So doing the area of the sector is the same thing, except since we're not finding arc length, we're finding area. So you're going to, instead of using the circumference right here, you're going to use the area right there. So it's still x over 360, but it's times the area, which is pi and then r squared. So we're going to substitute the same numbers but into that. So we still have a 38 degrees. So parenthesis 38 over 360. But we're now multiplying by pi r squared. So pi times, and then my r is still 35. So 35, but I have to square it here. So the area of that would be 406. I just rounded that real quick. And that would be whatever the units are squared, because that's area. All right, we're getting close to the end here. Measure of, if the measure of DB is 112, what is angle ACB? Remember, arc measure and central angles are the same thing. So this angle is also 112. These form a linear pair, so I would just have to subtract 112 from 180, and that's going to be 68. It says if DA is 27, that's the diameter the whole way across, so my radius is going to be half of that, which is 13.5. It says find the area of the entire circle C. So area is pi r squared. So I just want to do pi times 13 and a half squared. So pi times 13.5 squared. 572, roughly. Did I round that wrong? Yeah, it should be 573 if you round it up. Last couple here at the bottom. The measure of arc JL. Well, remember, arc measure is the same as the central angle, so that's 50 plus 60, which is 110. Arc length, we're using the same formula we did up here. So our central angle over 360 times the circumference. So MK is 100 plus 60, so that's 160 over 360 times 2 times pi times the radius. JD is actually the radius, so that's your formula there. Let's do that. 160 divided by 360, close the parenthesis, times 2 times pi times r. So that is 25.13. What was that? It's cut me off there at the bottom. This one, find the value of x and y. So this is about inscribed angles. If the angles are intercepted by the same arc, then they're equal to each other. So if you look, this angle here, DAC, this angle, it opens up and it goes to the arc that is D to C. And if you look at this angle here, this angle goes to the same arc. So it goes to D and it goes to C. So these two angles here at the top are congruent to each other. So we would find x quickly by setting these equal to each other here. So if I add 1, I get 18. If I subtract 4, I get x, so I get x is 18. And then my y's would be the same concept. So they go to A, and this angle goes to B. So this angle here goes to A and B. This angle here goes to A, goes to B. So it intercepts the same arc. So these expressions are also equal to each other, which would get me y is 21. All right. That's it for this video. Thanks for watching. There is a part 1 that goes over the first 2 pages, so if you haven't watched that yet, you might want to go check that one out too. Always like and subscribe to the channel.